All right, we're in section 3.1. If there are no questions about your test, everybody's good there? All right, I thought you did well. I'm very pleased with them. Your midterm grade has been entered into the, and again, this is the semester fall 2025. If you're not in fall 2025, you can disregard this part. But your midterm grades have been entered. Your lowest test grade was dropped, so you had your highest test grade and all of your homework average. And so that is where we were. So today I gave you your hybrid assignment, and that's going to be due a week from Wednesday, which is the 15th. Again, this is fall of 2025. It's the 15th because we have that holiday. All right. So first of all, I know that we know it already, but I still need to cover it just to make sure that we have it. Let's say that you had a matrix that looks like this. And so that's the formal name for the matrix. And of course, those are all lowercase a's, which represent the elements of the set, and they have their positioning. So 1, 1 would be in row 1, column 1. And the capital A represents the name of the matrix. So the determinant symbol can be written like this. That's your symbol for determinant. It can also be written like this. That's also a symbol for determinant. So you may see it either way. So when you find the determinant, remember that you take your principal diagonal, which would be A11, A22, minus your secondary diagonal, the product, which would be A12, A21. Okay, and we've done that a whole bunch of times, right? So A is actually equal 4, 5, 7, -1. Let's find A. Okay, so I'll give you a head start on that one. Now, in our last class, something was said about, well, that was in the formula for the inverse, but you did something else behind it. And that was a very good realization there that this is part of the inverse formula, but it's not. I'm not asking you the inverse at this place, at this time. So my main diagonal, the product would be -4, minus my secondary diagonal would be 35. And so this determinant would be the number -39. Okay, and so that'll be the first thing. I think that's probably on your hybrid assignment that you have. That's going to be your first objective from this section, 3.1. Now, what if you have, that's how you do a 2 by 2, but that's the only one that you work that way, right? So what if you have a 3 by 3? Okay, well, there's two different ways to do it. There's the formal way to do it, and then there's also a shortcut. So when you have Dr. McPherson next semester, whoever has to take him for physics, you're going to find the matrix by the shortcut more than you are the formal way. So it says, if A is a square matrix, then the minor, and the minor has the notation capital M, I, J. Okay, so I'll finish my sentence in just a minute, but that is your symbol for minor, and that's a capital M with an I and J, where I represents the row and J represents the column. The minor, MIJ, is the determinant of the matrix obtained by deleting the ith row and jth column of the matrix. Now, I paraphrase that definition. So if you want the actual formal definition, of course it is in your textbook. You're saying things like ith and jth. I am. Now, so let me explain to you what that is. It's really easy. It's just an arithmetic operation. I'm going to call this matrix A. And I want you to find these guys. We'll find that one. And this one. Now, so I'm asking you to find M11. So what that means I'm going to do is I'm going to delete the first row and first column. Now, I'm on this fancy board up here, right? So I can do that. So I know it's going to be left with 5, 9, 2, 6. Okay? So I always have to use my matrix again, right? So I don't want it just completely marked out. But when I take out the first row and the first column, I'm left with 5, 9, 2, 6. Okay? So I take the determinant of that. So it says it's the determinant of the matrix obtained by deleting the ith row and jth column. So I deleted row 1, column 1, and that's what's left. So when I fix this, when I take the determinant of it, I'm going to get 30 minus 18. So my determinant is 12, and that is the minor. If you have any questions with it. All right, so now we're going to take the second minor. It said, now the biggest hurdle here, you'll have another hurdle in a minute because you have to keep it separate from something called a cofactor. But the biggest hurdle right now at this point is which one is row and which one is column, right? So remember, this is your row and this is your column. So this time I'm going to delete the third row and the second column. So what that leaves me with is 1, negative 7, negative 3, 9. 1, negative 7, negative 3, 9. Now, when we take that determinant, be careful with your signs. The signs get you sometime. You get 9 on your primary diagonal minus a negative times a negative is a positive 21. And 9 minus 21, I think, is a negative 12. And that's what we would get for that one. You'll say, okay, what's the point of this? We're getting to the point. I'm just building the clock, as they say. But that's how we would find that minor. Do you have any questions with us? So the next step in this process is to find something called the cofactor. The cofactor Cij. Okay, so that's understood to be a capital C. You can't really tell because C looks the same capital and lowercase, but that's a capital Cij. And it equals negative 1 to the I plus j times Mij. Okay, so we're going to find a minor like we did in the first, except for after that we have to put this sign variant in there. So sometimes the minor and cofactor have the same sign, and sometimes the minor and cofactor have different signs. The only way a minor and cofactor can differ is by a sign, and that is my favorite short answer question to give you. So I might ask you a true, false. Are minors and cofactors always the same? No, false. Are minors and cofactors always different? No, that's false. At most, minors and cofactors differ by a sign. That's true. Okay? Now, there's another way. Oh, there we go. There's my good page. There's another way to find the cofactor sign pattern as well. Okay, when I give you a determinant, other than a special case that I'll give you that's a triangular matrix, all my determinants I'll give you are either be 2 by 2 or 3 by 3. So a 3 by 3 determinant would have this cofactor sign matrix. Okay, and you'll say, what on earth is that? So when you're finding the cofactor, you can either see what position it's in, and this is what sign goes in front of the minor, or you can do it this way. So what I mean by that is let's just take position 1, 1. Okay? So for position 1, 1, I'd say that's negative 1 to the 1 plus 1 times m1, 1. So this would be negative 1 to the 2 times m1, 1. What's negative 1 to the 2? 1. And more importantly, it's a positive 1, right? So what's in position 1, 1 would be this guy. And so you can learn it by the cofactor sign matrix, or just do the 1 plus 1. I don't care. Whatever works best for you. Let's do one more just for fun. So let's do C1, 2. Okay? So C1, 2 would be negative 1 to the 1 plus 2 times M1, 2. So this would be negative 1 to the 3 times M1, 2. And negative 1 to the 3 is what? Negative. So whatever your M1, 2 right there was, you would put the negative in front of it, which is going to change the sign of it. But the way that I got that negative, I could do it by negative 1 to the 3, or I could remember, hey, whatever that M1, 2 is, put that in front of it and see what happens. Okay? So either way, that's how you would adjust your signs. All right, so let's try some of these. I don't know if this was the same matrix as earlier. It might be. That's okay if it is. I already can't remember what it was. I don't think it's the same. Okay, good deal. All right, I'm going to cheat on you guys and do this. 1, 2, 3. 3 is all I need. Okay, but you know me. I like to write out every step, right? So I see this much. You can probably skip some steps, but I have to write everything out. It's a curse. So when I'm working this one, I see M2, 3, which means row and column. I usually put that in there when I work my problems as well, so I don't forget. This is row 2 and column 3. So what's left over is negative 4, 1, 3, 3. Negative 4, 1, 3, 3. Okay, which is what we did on the previous slide. So when we work this one, we're going to get negative 12 minus 3, which would be a negative 15. And that's what I get. Now, let's look at C23 going straight across. Well, C23 is going to say negative 1 to the 2 plus 3 times M23. So this is going to be negative 1 to the 5 times negative 15. What's negative 1 to the 5? Negative 1. So negative 1 times negative 5 would be a positive 15. Now that's the way that I do it. I don't really write down that checkerboard pattern, but you could certainly write down the checkerboard pattern. Here's how it would look. And of course that checkerboard pattern doesn't mean that the answer has that sign. It means that that is what you put in front of the minor. So for element 2, 3, that's right here, I would take that value, put it in front of negative 15, and my answer would be 15. And so that's how you're thinking about that one. All right, so that's how they're going to work. Do you have any question with the first one?
You wrote 2C1.
I did.
I'm guessing one was supposed to be M1.
I don't know why I wrote 2 of them. One of them is supposed to be 3-1. All right, so we're going to do C31 and C12. Let's do C31 first. Okay, so earlier I said, okay, we might have a little trick here. One of the tricks is remembering which one's row and column. So that's one of the little hiccups. The other one is a lot of people, when they do the cofactor, they forget the sign. So remember the cofactor matrix formula? You don't have to write it, but it actually says do this. Okay, so that's what we're actually doing. So negative 1 to the 4 would be negative 1 to the 4, which is positive 1, right? Times M31. Okay, so now we need to find M31. So I'm going to take out my third row, first column. And what that leaves me with is 1, 7, 0, negative 2. I already took care of the sign right here. It was positive. So that answer is going to be negative 2. Any question with it? Okay, so you have one more on your page, C12. You try that one. I'll catch up.
Does it work with any matrix, or is it just square matrices?
You can only find the determinant of a square matrix.
It would probably be different. 4 by 4.
I would think it would be the same. I don't know for sure, but I would think it would be the same.
It still
Kind of.
alternates each.
Uh-huh.
Got it.
Are you using the matrix feature of your calculator? Is that what you're...
Yeah, I was thinking at some point I could.
So just double check behind me if you'd like. Yes, go for it. You're not supposed to be able to take, it is my understanding or what I remember, but it could be false, but you cannot take a determinant unless it's square.
I mean, that would make sense. To me.
But if you want to question it, feel free to check it in your calculator. All right, so what did you get for C12? Let's see. Okay, so we get a -1 out in front as our sign from our sign work. And we're going to get a -5 minus a -6. Watch your signs. -5 minus a -6. So that's -1 times -5 plus 6, which is -1 times 1, which is -1. And that's how that one will look.
And save spring guard just to write out all the signs.
What now?
It just saves spring guard write out all the signs. I guess.
Okay.
So like
Everybody has their own way to work it, so if you'd rather write all the signs, that's perfectly fine.
So like writing out -5 minus -6 instead of -5 plus 6 immediately.
Gotcha.
Yeah.
More people miss it. The reason I always write it out is more people miss it right there than they miss it any other reason. Oddly enough. Any questions with them? All right, so what was the point of it? Well, now we are about to find the determinant, and it's called expansion by cofactors. So it says if A is a square matrix of order 2 or greater, so it does say right there again it has to be square, then the determinant of A is the sum of the entries in the first row of A multiplied by their cofactors. This is called expansion by cofactors of the first row. Now, the book calls it expansion by cofactors of the first row, and I will tell you where you can find that in your book so you don't have to copy it down for me. It is the definition of the determinant of a square matrix. For my textbook, it's on page 112. So if you need that, that's where it's located. Again, what it means is it is the sum of the entries in a row multiplied, let's say each multiplied by its cofactor. Now that's me paraphrasing it. Now technically they usually do the first row, but you don't have to do the first row, nor do you have to do a row. You can do a column. And this is how you find the determinant. Okay, so let's say that I asked you, just to prove this little part here, let's say I gave you this matrix, matrix A. I think it's a -4. Let's say I asked you to find the determinant. Here is what that statement above means. It means I'm going to take the element 2, here's where I get it, and I'm going to multiply it times its cofactor. And then I'm going to take the element -4, and I'm going to multiply it by its cofactor. And then I'm going to take the element 3, and I'm going to multiply it by its cofactor. You don't have to write that out there, but that's what it says. It's the sum, which means we add them up, of all the entries in any row, all the way across, multiplied by its cofactor. Now, that's how we would do it on the first row, going across the first row. But technically, to save us some time, the second row would be easier because in the middle you'd have a 0, right? And so you can pick any row or any column, and you're going to get the same determinant. So what we're going to do with this one is we're going to find C11, C12, and C13, and we're going to find our answer, find our determinant. So now that we've done a few, I'm going to go a little faster with it. C11, okay, so I take out the first row and the first column, and that leaves me with 0, 5, negative 6, 2. We'll fix that in just a second. So the second one, we go boop, boop. Sometimes I'll just mark them that way. 1, 5, 7, 2. Row 1, column 3. Now, you can do the negative ones like that, or you can remember that, hey, this one's in the first position, this one's in the second, and this one's in the third. You can also remember them that way. This is going to be a positive 1 times 0 minus negative 30. So this is going to be 30. And this is going to be negative 1 times 2 minus 35. Which will be 33. And this would be 1 times negative 6. So putting those in there, we're going to get that the determinant is 2 times 30 minus 4 times 33 plus 3 times negative 6. What? You should get negative 90.
That's what I had.
Great. And that's your determinant.
Now when I'm looking through the math test, I didn't find the determinant, so I just set it over on Google, and yeah, Google had confirmed that, yeah, the non-square matrix does not have a determinant.
Great.
So yeah, that only applies to square determinants. Oh, sorry, square matrices.
So that's that one. We're going to definitely practice those more as the week progresses. And then there's also a shortcut with diagonals, and so I'm going to show you that one on Wednesday. There's one more that I want to do that came from this section, and then we can say we finished up this section, and then we'll be good to go. And it looks like this. And you had one like this on the last test, actually, so I'm asking it twice. But this one's a little bit harder. And the reason that this is brought up yet again is that when we start doing eigenvalues and eigenvectors at the end of this testing period, eigenvalues and eigenvectors have something like this in their work. Okay, so we're looking for this such that A is singular. So remember, something is singular when its determinant equals 0. Okay, so let's call it A first of all. There's A. I'm going to take the determinant of A. So the determinant of A in this problem would be this part minus this part. main diagonal minus secondary diagonal, and the product's there. And remember, we want to know where this is singular. So what we'll do with this determinant, let's go ahead and find the determinant first. So we'll find the determinant here by FOILing. Okay, so that's my determinant. Okay, so I want to know where this is singular. So it's going to be singular when that value right there equals 0. So we'll solve it by factoring. I won't give you anything that wouldn't factor, even when we get to eigenvalues and eigenvectors. So k would equal a -3 and k would equal 2. And those are the ones that make this matrix singular. Okay, let me look at one more thing. Okay, so I gave you a hybrid assignment and you have over a week to do it. You can work that whole hybrid assignment right now except for number 4, because in number 4 I tell you to use the diagonal method, and I haven't shown you that yet. So if you want to start looking at it, feel free to do so. In the bottom, number 5, I said find lambda. So this symbol right here is your Greek letter for lambda. It reminds me of the broomstick in Beauty and the Beast for some reason. I just think of it just dancing. And so that's lambda. And of course those bars mean find the determinant of it. So where I say find lambda such that the equation is true, that's this exact problem right here, except I use k's instead of lambdas. So you'll find that determinant with your main diagonal minus your secondary diagonal, and then set it to 0. So that's just like number 5. So the only thing I haven't done with this one is number 4. Now, before we call it a day, you had section 3.2 last time. I just want to refresh your memory on that. So there was a handout from section 3.2 where we did a whole bunch of 2x2 determinants, so that was fun, right? And so on the back of that handout, it said, if you perform this operation, it affects the determinant in this way. So you had those. You also had conditions that yield a 0 determinant. So we did those as well. So as far as this test period goes, of course, we just started it, but we have section 3.1 under our belts and section 3.2. Okay, and when you come in on Wednesday, we'll start back over with those 3x3 determinants, and we'll work extra ones. We'll work them by the shortcut method, and we'll work them by expansion by cofactors again. Come on.